we can actually go and look at what happens if we have impurities in our sample from our solvents that we're reacting. And so if you're on campus, you can easily click on this document. It's also on the portal if you're off campus that you can look at this file. There's going to be that same handout under NMR solvent impurities. So if you are off campus, this is the place to get it. If you're on campus, you can always click on the link in your notebook. That these chemists actually ran NMR solvents, reaction solvents and various NMR solvents, and looked at where they lie. And so for you guys, we're going to be mostly using chloroform D, which is CdCl3. If there's any traces of water, we tend to see these residual signals, but sometimes we see them anyway. Residual signals are basically if we pick up a hydrogen or replace a hydrogen for that deuterium, so this becomes CHCl3, you're going to see a peak for it that corresponds to what you see in this top row. So for instance, chloroform D, when it has a residual peak, either because there's a little water or there was some extra CHCl3 chloroform that was left in the sample before the bottle was shipped, we have a peak at 7.26. So typically you're going to see a peak at 7.26 in most of your, so you're typically going to see a peak for 7.26 in a lot of your samples. It may be very little, but if you have a lot of water, you're probably going to see a lot of this peak. And that being said, if you have water, you should also see a rounded, more broad peak for the OH on water as a singlet at about 1.56 in chloroform. And so if you start looking at this table, these are the various NMR solvents. THF D8 is the first row, C2Cl3, so that's dichloromethane, deuterated dichloromethane in chloroform. We're mostly going to do chloroform, or DMSO, which is CD32SO. And we're going to focus just for this for the chloroform part. So if you had water, you would see a broadened OH peak as a singlet at about 1.56 roughly. If you had acetic acid, you're going to see a singlet for CH3 at about 2.1. So you're going to be a little smart. What solvent did you use in that lab? If you know that you use, for instance, diethyl ether, then the first thing you should do is make sure you know where diethyl ether is. So if you don't get rid of all the diethyl ether from your reaction, you may actually see the peak still in your sample for the NMR. So one of the things you want to do is have this table handy. So if, let's say, we had ethyl acetate left over in our reaction, looking at the chloroform column, I should have a singlet that shows up around 2.05, a quartet that shows up around 4.12, and a triplet that shows up at 1.23. And so if we remember what the structure of ethyl acetate looks like, it has a CH3 next to a carbonyl. That carbonyl is next to an oxygen, and beside that oxygen is a CH2, then a CH3. Now if we go to the next page, we have a carbon NMR version of this. And so if you have it on the proton NMR, it better be on the carbon NMR. Otherwise, it might be something different. Okay, so just because it's you see even one or two of those peaks, then you need to have all the peaks for them to be present. So for instance, again with ethyl acetate, if you see a peak at 21, 171, and 60, then it's probably, and 14, it's probably ethyl acetate. However, if you only see 170 and you see 14, it can't be ethyl acetate. All of those peaks have to be there. And so you always want to keep this table handy. Maybe print it out and highlight the chloroform. This is very important. And just like we talked about on the NMRs, on carbon NMR, there's a peak at 77, which comes from CdCl3. And then in the DEP, remember, there's no hydrogen on the carbon, so it doesn't show up in the DEP.